Ninth Class Physics. New Book. 2025. Chapter number 4. Short Questions. Question number 1.
Define like and unlike parallel forces. We call parallel forces acting in same direction like parallel forces, and those acting in opposite direction unlike parallel forces.
Question number 2.
What are rectangular components of a vector and their values? Components of a vector which are perpendicular to each other are called rectangular components. Horizontal component fx is equal to f cos theta. Vertical component fy is equal to f sin theta. Question number 3. What is the line of action of force? The line along which the force acts is called the line of action of the force. Question number 4. Define moment of a force and prove that tau is equal to Rf sin theta, where theta is the angle between R and F.
Moment of the force, or torque, is defined as the product of the force and the moment arm. Let a force F is applied on an object at point P, which is at a distance r from the origin. Angle between R and F is theta. Horizontal and vertical components of F are F cos theta and F sin theta, respectively. There will be rotation only due to vertical component of force, and no rotation due to horizontal component of the force, because the line of action of horizontal component of force will pass through the origin. We call perpendicular distance from the line of action of force to the origin the moment arm, denoted by R. Torque is equal to moment arm into force. Tau is equal to Rfy. Tau is equal to Rf sin theta. Question number 5.
With the help of a diagram, show that the resultant force is 0 but the resultant torque is not 0. It is a required diagram because in this diagram, two equal and opposite parallel forces are acting on an object. Their sum will be 0 because they are in the opposite direction, but the object will rotate, as you can see the definition of the couple. Two equal and opposite parallel forces produce torque. These two forces having same magnitude and opposite direction will give us 0 resultant force.
Question number 6.
Identify the state of equilibrium in each case in the figure given below. First two objects are in unstable equilibrium and the last one is in neutral equilibrium. First two objects are in unstable equilibrium and last one is in neutral equilibrium.
Question number 7.
Give an example of a body which is moving yet in equilibrium. A car which is moving on a straight road at constant speed is in dynamic equilibrium.
Question number 8.
Define center of mass and center of gravity of a body. Center of mass of a body is that point where the whole mass of the body is assumed to be concentrated. Center of gravity is that point where total weight of the body appears to be acting.
Question number 9.
What are two basic principles of stability in physics which are applied in designing, balancing toys and racing cars? In balancing toys, their center of gravity always remain below the pivot point. If we disturb the toys in any direction, we raise their center of gravity, making them unstable for a moment. It comes back to its initial stable position by lowering its center of gravity. In racing cars, we keep its center of mass as low as possible. We also increase its base area by keeping the wheels outside of the main body.
Question number 10.
How can you prove that the centripetal force always acts perpendicular to the velocity? The direction of tangent at each point on a circle is different, therefore the velocity of an object moving with uniform speed in a circle is changing constantly. An object moving with uniform speed in a circular path always requires a force perpendicular to its direction of motion. This force is called the centripetal force.